This is the 1 year anniversary of the first ever meetup. We should do something special for this big event, but I just realized it today that it is 1 year because I was looking at the YouTube channel and I saw that last year the first video got uploaded like 2 days, and 2 days ago, 1 year ago. So I figure that this is the 1 year anniversary. So happy 1 year anniversary, everyone. It's been an awesome ride. We've had some absolutely incredible speakers, and I think it's only going to keep going up from here. Those are all of the announcements. There's my commercial is done. Now we get to listen to Daniel and all of your wisdom, man. So thanks again for joining us. I think it would probably be worthwhile to hear a little bit about yourself and what you're doing right now at your current position.
Yeah, it's a great question. So if for those of you who hopped on right at the beginning of this, you probably heard Demetrius and I talking about how we both had stints in Spain. And then I actually grew up there from the ages of 7 to 18 and came back to the United States for college. So went to college in Michigan, learned that I did not like the cold that much, moved down south to North Carolina for my master's degree and started my career in financial services, where I've been for my entire career. So I started out in risk management at a small community bank, wanted to see how I would stack up against the talent at a larger bank. So I moved to BB&T, which is a very large bank in the Southeast. They merged recently with SunTrust to become, I think, one of the top largest banks in the United States. After that, I moved to a small subprime lending company in South Carolina, which, for those of you who are big data geeks, subprime lending is the place to be. Subprime lending has so many defaults that you actually have a relatively balanced data set, which is very unusual in the credit space. So it's a data scientist's dream, even if it's an accountant's nightmare. And then after a short stint there, I moved to where I am currently, which is Regions Bank, where I started out in model risk management and validation, which I think we're going to touch on throughout this talk a little bit. And then about 2 years ago, moved into the data and analytics space, where I'm responsible for the tooling, the platforming, the practices for our data scientists, and as well. And through that time, I've also gained an engineering team, a data engineering team, to help massage our data sets from our source systems into model-ready assets for our data scientists.
It might be nice if you can go through a little bit of the use cases. Sorry, I cut you off. So finish that thought first, and then maybe if you can.
Yeah, I have to finish the thought because Regions Legal promised that made me promise that I would say this. So any opinion that I make is not Regions' opinion; it's my own. So I just have to make that disclosure. I think I'm going to say only good things about Regions, so I don't think I need to make that disclosure, but I've made it. And also, just to give a little bit of background on Regions, we are $147 billion in assets. We're a financial institution based in the Southeast. We are the 21st largest bank in the United States, and we ranked #1 in the JD Power survey for regional banks. So we have a definite focus on a customer, and I think we do a really good job of meeting our customers' needs overall, and in data and analytics in particular. And we help with that with some of the data products that we create to help tailor the customer experience.
Well, I'm glad we got that out of the way. The legal team is always, you don't want to get on their bad side.
And they're really great. So I made a little bit of fun there, but they really make sure that we're in a good spot and allow us and enable us to do these kinds of talks.
Awesome. So yeah, what kind of stuff what kind of use cases are you working with? I imagine a lot of fraud detection, and you talked about lending before. How are you doing stuff with that here too?
So the data and analytics team overall is focused on what we would term data products, which are end-to-end applications that happen to use data or machine learning as a part of the application. So an example would be fraud, where we have embedded our models in the fraud workflow. We also tend to focus very much on applications that tend towards machine learning. So a lot of the models that you might associate with banks, like lending or stress testing or economic capital, some of those are really complex mathematics, but they aren't machine learning. So those are typically handled by different groups. So in data analytics, we really focus on quote unquote big data solutions that require large amounts of historical data, use machine learning algorithms to make those predictions. Some of the other use cases, one of the big ones that we hit the ground running with when the data analytics team was first stood up about 2.5 years ago was one that focused on our commercial clients. So just identifying which commercial clients we thought could use some more solutions. So it was a share a wallet type product where we said, hey, you've got these 10 products with us, but do you know that we also offer like these 5 additional products and it looks like you could really use these. Also, we had a module for retention. So if we thought that there was a concern about a customer maybe leaving us, our models would identify those and surface them up to our relationship managers so they can make that informed call and hopefully head off a potential attrition. So those are some of the things that we're working on. We're definitely looking to focus more on the consumer as well. So making sure that we have that personalized experience. Obviously, every financial institution is trying to find that segment of one, if you will, and we're no different.
These are huge, beneficial, like business values, right? These are what you're talking about right now. I could see that the use cases are very, very popular for adding value to the business. And when we talked before, you mentioned that it was not exactly the sexiest infrastructure or the newest shiny toys that you all are working with, but you are able to get, you tote 100% of the models into production. And I was like, wow, that's a big number, especially when you hear from everyone else saying that they only can get 20 or less. And Gardner is saying nothing's getting into production these days. But maybe it would be helpful if you can talk to us a little bit about your stack, what you're working with, and how the legacy has been useful or not so useful.
Yes, that's a great question. And I'm going to probably explore that question in several different avenues throughout the rest of this talk, but particularly with our stack. And by the way, I apologize in advance. We have a major storm coming through. And so if you hear thunder and lightning and maybe a tornado or hail, that's what's happening. And hopefully I don't lose power. But just in terms of our stack, today we are on-premise, we are Hadoop-based, we have a Hadoop-based data lake, and the data lake really serves as the underpinning for all the analytics that we do within the data and analytics team. So first off is the data lake. On top of that, we have a Cloudera data science workbench, which is a way for our data scientists to interact with that data lake. For those of you who are familiar with Spark, especially on-premise, it can be very tricky to or have a steep learning curve to interact with that environment. So one of the first things that I did when I joined the data analytics team was say, hey, let's get something in place so that our data scientists can interact in this environment in a way that's familiar to them. So let's give them a Jupyter Notebook interface. Let's give them an IDE that they are able to, out of the box, connect to our big data cluster and do their big data analytics. So we use Spark a lot for both data engineering as well as for model training. And then on the DevOps side, we use Bitbucket for our Git version control, our Git server. And we use Bamboo, which is another Atlassian product for continuous integration, continuous delivery.
And so I know there are some ideas here about like DevOps practices that you've brought into ML, and maybe you can share a few of these. What are some DevOps practices that you think go well with what you're doing right now in machine learning, and maybe some others that aren't going as well?
Yeah, so when I first joined the data analytics team, my vision, so my concept was model training is going to be very similar conceptually to software compilation. So models take code and they take data and they produce a model object, a binary, And software, they take their code, they compile it to a binary and serve it up as a microservice or what have you. Wherever you want to put that binary, you can put it. So to me, the model training part was very similar to a CI/CD pipeline. There's obviously some additional complexities. There's a dependency on data, often dependency on large amounts of data. There's also a different computational need. So model training is obviously a different order of magnitude, typically, or even more difference in terms of the complexity algorithmically or computationally than a traditional software compilation. So those things definitely make it a different kind of practice, but I went into it with that mentality. I realized that that was a good mentality, and I still retain that mentality, but it didn't necessarily jive with the way that our data scientists were really thinking about our data science workflows. So instead, I try to extract the primitives, if you will, of the data science process and find ways to make the DevOps work with those primitives. So in our case, the three primitives that I think are really important for all of our models, regardless of algorithm, regardless of architecture, is a training pipeline, which takes feature engineering code and label engineering code if it's a supervised learning problem, and outputs as part of that pipeline a model object, whether that's a pickle or a Spark ML serialized model in HDFS, or in our case, we use MLeap to serialize our Spark models. Then we have a scoring pipeline, which takes our feature engineering code as well as our model object as inputs, and then creates predictions from that pipeline.
Okay.
And then our third and final pipeline is a monitoring pipeline, which takes the label code from the feature engineering pipeline or from the training pipeline, as well as the predictions from the scoring pipeline, and compare the two. So we have ground truth to compare with our predictions, and we're able to do monitoring on an ongoing basis of our models to make sure that they're still performing adequately. So those are like the three primitives that we think about. And I think that that's going to be a go forward, no matter how our stack looks in the future. I think those are really going to be the three primary ways that we think about that. Because if you think about it, those scale to really any type of structure, whether it be streaming, microservice based, you always are going to need some sort of training pipeline, scoring pipeline, and your monitoring pipeline you might be able to do as a add-on to your scoring pipeline. It depends on your infrastructure, but it's still very important for us, especially in a banking sense, to be explicit about these are the controls that we have in place in case our models start misbehaving.
So you spoke about the complexities that are added onto this, and maybe before we jump into that, sorry, just a quick comment on these three different principles. I love the way that you look at it and that you simplify it and say, hey, we're going to need this no matter what. Let's keep these as like the basics. And then we build our foundation with that and build everything else on top of it. And I wanted to jump in a little bit because I know banking and the financial sector is so rigorous when it comes to regulations. Mm-hmm. And so how do you deal with the regulations of, say, like reproducibility?
Yeah, and just to give some more background on what the regulations really come from. So there's I don't even know what the right word is anymore, a letter, a regulatory report from the Fed. It was a joint report, I believe, called SR 11.7, which came out in 2011. And this really required a third party, essentially, or somebody not involved with development, to review all models at banks. So even when I was at my community bank right out of college, which was a very small community bank, we still had to have somebody look at our models and validate it and say that it was appropriate or okay to use. In that case, we actually had a relationship with the university, and they would, one of the professors would give this almost as an assignment, not an assignment, but like something that their grad students would be able to look at to get a feeling for how the industry worked. Mm-hmm. Obviously, in a bigger bank like Regions or at BB&T, we have a dedicated team that will review all models at the bank. So I actually was in that team when I first joined Regions. So I was validating the models before moving over to the data analytics team. So that's kind of the background. And there you can read SR 11.7 if you Google it. It's not that long, but basically it does require a lot of evidence around your developmental work. It requires exploration of a variety of algorithms. It requires an ongoing monitoring plan, an outcomes analysis assessment, as well as that second line review. So that's kind of the background to the regulation that around models in particular. When it comes to reproducibility, I would say it is a big deal. And I would say it's a big deal in part because we just haven't been very good at it as an industry for quite some time. We haven't used automated version control. So when I was at BB&T, for example, that was one of the things that just blew my mind. It was like, how are we developing code without version control? Like, this is something that we could just put into place and we'd automatically have so much more control and ability to reproduce the things that we're creating, regardless of whether it's models or not, just code in general. Can we reproduce what we had a month ago if we aren't versioning?
Totally.
So that's part of it. But yes, we do have a stack that allows for reproducibility. So we have, I mentioned our on-premise Hadoop data lake. One of the great things about HDFS is that out of the box, it's you can't update it. It's immutable. You can destroy a partition and reload it, but it's more difficult to manipulate the data in it than it is for a normal database. So it's append only in most cases, and that's how we use it. So we have an immutable data source going back a decade from all our source systems. So it helps, right? If I need to reproduce any result or any model that we created in the last few years, all I need to do is say this was the time window, and that data will still be there for me. Then we have the concept of both code versioning, which I think I already mentioned. We use Bitbucket for versioning for our Git server. But we also have the concept of model versioning, and I'll describe a little bit what that looks like. So one of the ways that I ensure that we can reproduce everything is by requiring that everything that we do from all those 3 pipelines that I mentioned, those all have to run in production. So the training pipeline isn't something that a data scientist is just exploring in a Jupyter notebook and is coming up with an object that they then copy over or move to an environment that is used for scoring. That whole pipeline, that whole training thing has to be rerun. Obviously they do that, right? They have to do that as part of their exploration. But that work then gets redone, so to speak, automatically in our production environment to recreate that model object, which is then, we then have the provenance over that whole process, right? We have that pipeline that's been promoted through our GitOps approach, through our CICD pipeline, we have that visibility. The way we actually ensure that the code is being written in a way that allows for us to execute that pipeline is that we wrap all the Python code that the data scientists create as a library automatically. So every time that we create a new version of the code, which is every time that we make a merge of code into the main branch, it automatically increments a version of that code. So whenever that happens, we actually deploy that code automatically as a Python library to our internal PyPy registry. So what that allows us to do in production is then just pip install the version that we need to run, and then execute the Python code that's within that package. So that's how we get how we achieve the provenance, right? We have the CI/CD pipeline that ensures that the only way to actually run a pipeline is through that process, and that we have full visibility. We pip install it. We have packaged it up as a library so that there's no ambiguity about where this came from. And the third one thing I did forget to mention is that we also version our model object and push that to an object store using the same versioning technique as our Python library. And then our scoring run is automatically set up to take that model object at runtime. It's going to download that model object and run predictions off of it. And what was the other thing I was going to mention there? I'm sorry, the thunder is fast approaching, so that's distracting me a little bit here.
I wonder about how you're dealing with dependencies, because you mentioned that earlier, and I know that's something that has come up quite a bit. And first of all, props to you for this mentality of, and it was like last week, Igor said, I don't like to prepare things for like POCs. I like to prepare things just for production from day one, so that you're not stuck in this like having to go from a POC, then make the leap to production.
Yeah.
And it seems like you kind of echo that sentiment, like get it ready for production from day one. But is there a way that you have found that is manageable for these dependencies?
And by dependencies, do you mean like library dependencies, like Python library dependencies?
Yeah.
Yeah. So we require that every dependency be specified in our, you could do it in a requirements.txt file. We use setup.cfg file, where you have to explicitly list your dependencies and the version that they are, that is being used. And there's no firm requirement that you specify the version, but it's kind of on you if something breaks because of a dependency mismatch. So one of the things that we do try to do, and this was actually one of the things that I wanted to make sure that our data scientists had right out of the gate, was the ability, I wanted them to have more ownership of the production environment than I think is typically allowed at a lot of companies, but while still retaining the controls and the governance that's needed and the transparency that's needed. So that was one of my first challenges. How do we enable that? And how do we meet the data scientists where they are? Because the data scientist might just be like, hey, I scripted this thing in a Jupyter notebook and I created a model and I'm done. And they're right in thinking that, right? I want them to follow that pattern, and I want to be able to enable that pattern, but I also need to make sure that we have that done in such a way that they don't have a problem in production once they go there. So a couple of ways around that we dealt with that. One is just like I said, we set up those pipelines for them, and we did it in a way that's modular, so that when they create a new product or a new project, we developed a command line tool for them, and it's called Create Data Product. They go in there, they type Create Data Product. It's literally called Create Data Product. And ask them a few different questions. It was modeled off of Create React app, if any of you used React. And you answer a few questions about the name of your project and whether it's a Scala project or a Python project. And you press enter, and it scaffolds the entire project for you right out of the gate. So all you have to do is get this merged into the main branch of your Bitbucket repository, and automatically we've set up the pipes, if you will, for deployment to our production interface. But the only way to do that is if you get approval, right? We don't just let anybody merge into the main branch. You are required to have approvals to go. We use a variant of the Git flow paradigm for version control. So we have a dev branch, a main branch, and then feature branches off the dev branch. So you have to get approval to get into dev branch. And then we only merge into the main branch every 2 weeks or so. Whenever we're at the end of our sprint, we need to release a new feature.
Oh, that's super cool. And thanks for
So from a
breaking
data
that
scientist
down.
perspective, it's all done behind the scenes by that tool, essentially. And obviously there's work that we've done as a team, my team has done to make that seamless. But from a data scientist perspective, they are just playing around with the Jupyter notebook, and then they're able to, once they get that approval, which usually comes from a data science manager who's very involved with the project, they'll see the results in production without even having to know. I'd love them to know. They're welcome to explore it, but without them having to have that hurdle of understanding Docker or understanding CICD or DevOps tools.
It reminds me a little bit of a presentation we had like 6 months ago now from Nelson, who set up basically scaffolding on top of MLflow, and they open sourced it and called it Hermione. Shout out to Nelson. And if anyone wants to check that out, you can see it on our YouTube channel or podcast. But I like that. I like the way that you're thinking about that, because the quote there is meet the data scientists where they are. If they want to go deeper, they can. But if they don't want to, it's already there for them, and they can just focus on what they want to focus on and where they feel like they can add the most impact. So there's a question coming through here in the chat from Ron, and shout out to Ron asking if there's any swag. He won some swag a few weeks ago. So, Ron, not today, man, unless you want some banking pens. I don't know if Daniel has any of those he can give you. But the question is, what's your tech stack for scoring pipeline and monitoring pipeline?
Yeah, that's a great question. So when I first, so back to the question about meeting the data scientists where they're at. When I first got this, when I was first in this role, I really wanted all our models to be deployed as microservices, as REST APIs, essentially. And I was like, there's no reason why we can't make this happen. We have a Kubernetes cluster, we have a Spark cluster where we do our training, but that doesn't mean that we can't package that model object up and deploy it as a microservice. And in fact, I built a wrapper for our Spark models. So we use mLeap to serialize those models so that they're able to be run without having that Spark instance. Which I highly recommend, by the way. mLeap is a really great serialization if you're heavily into the Spark world. So I created wrappers in Scala to allow for very low latency scoring of our models. Even if you use PySpark, so if you're using Python to run training, you can still use mLeap to serialize it and then load it into a Scala application for scoring. So that was where I was going. That was what I thought we were going to move towards, and that was 2.5 years ago. And if you told me 2.5 years ago that I was never going to deploy a model with that architecture, I would have said I failed. I don't think I failed, and we haven't yet. So it's funny how things change. But it was actually through a conversation with one of the data scientists or data science managers, not within the data analytics team, but outside of the data analytics team. And I was asking about pain points, and he said. And I was talking about how we could have this paradigm where models are microservices. And he said, this is my current workflow. He's like, I have all these source systems. There's data in there that is large at some point times, but worse than that, it's not even that it's large. It's just that it needs a lot of manipulation to get it to a refined state where we can actually put it into our models for scoring. And I thought about this some. I'm saying, so well, how long does it take to run these pipelines? And he said, an hour or 24 hours, right? It could take a long time to run these pipelines. So I was like, how do we jive with a real-time microservice approach with these long batch running processes? And I thought about it. I'm like, well, we could make it happen. You'd have to use something like Redis or Cassandra, some low latency data store that's basically caching the results of the pipelines. And then you could make a real-time invocation of the model. And there's a couple different paradigms that you can work with, but the most basic would be have the model wrapper make a call to the data, the cache, if you will, and bring back the features that it needs to make the score. And I remember stepping back and thinking that is a lot of work and complexity. And if it's taking 1 to 24 hours to run the pipeline anyway, why don't we just do everything in batch? And that's where we're at today. Now, in 2021, I'm very hopeful that we'll have models that are deployed as web services, because we're going to have use cases, streaming use cases, on-demand use cases where it absolutely is going to be needed, where we have that low latency feature store and we have the model as a microservice, and it's going to be what I envisioned 2.5 years ago. But for the most part, we actually didn't need that. And it's so much simpler to just make everything batch-based. So to answer the question, we actually use Spark for all 3 pipelines today, but we're definitely looking for more flexible, I would say, or more microservice-based approaches to that in the future.
Famous last words. We can make that happen.
Well, I mean, we technically could, right? Yeah, we have all the tech that we need to make it happen, but it comes really back to meeting the data scientists where they're at as well. And as an organization, we weren't at that time really ready for the leap to a container-based, microservice-based approach.
Yeah, and is the squeeze really worth the juice?
Yeah.
Right? Like right now, I think you made a great choice there saying it's not necessary at this point in time. Maybe later it will be, but until we hit that, like, let's cross that bridge when we come to it, right? We don't need to fix a problem that's not actually there.
Yeah.
So I really like that. Now, Musa's asking, you hinted at Docker earlier. What do you use for container orchestration? I mean, you just mentioned Kubernetes, but now it seems like you're not really using that.
So it's a couple. So that there. there's several ways I could answer this question. So we have an on-premise OpenShift cluster, like a lot of organizations, which is Red Hat's version of Kubernetes. We haven't really deployed any workloads to that yet in the data science world. But we do use Docker heavily as part of our CI process. So we have, and our workbench actually. So our workbench, we have curated Docker containers for our data scientists to be able to spin up an instance where they might have a Jupyter notebook, but maybe they don't want to use Jupyter. Maybe they want to use VS Code. So we have a Docker container where they can spin up VS Code as their IDE. And we've also installed custom libraries in that environment, basically tailored it to our use case. So Docker has been instrumental there. And then in the CI pipeline as well, just to make sure that we have all the dependencies we need, we use Docker there as well. And we use a modified version so that it's not as large as the version that includes all the IDEs in it. But that's how we use Docker today for the most part.
So I want to jump around a little bit because I was doing some snooping with your friends and asking some of your colleagues what questions they would want you to answer. And I know that you've got some great friends because when I posted that we're going to be chatting on LinkedIn, your colleagues all, I don't know if you paid these guys or what, but they came in and said like, Daniel is the best at operationalizing ML. He has taken us from zero to hero. So were you paying them?
I was not paying them. It was very nice of them to say that.
So I guess it's, yeah, there we go. That is just a testament to what you have done at Regions Bank. And it's pretty spectacular to see. For me, I got excited when I saw them commenting on that because that's not something that happens every day. It's like, woo, we've got a good chat coming up. Now, one of your colleagues was asking about how does the model validation experience make someone better at operationalizing machine learning? And what do you look for when you're hiring?
Yeah, that's a really great question. So I would say, so I used to work in audit, which is what in banking we call third line. I also worked in model validation, which in banking we call second line. And I've worked in the quote unquote first line, which is where I'm at today. And it's based off of 3 lines of defense model that I think JP Morgan put into place sometime in the 2000s. And it's kind of the operating model for a lot of banks from a risk management perspective. Where was I going with that? So the second and third line approaches are to identify processes and then risks associated with those processes, and then controls that mitigate the risk associated with those processes. So it's almost like a 3-dimensional view where you have risks that come about from a operational process that you can then have controls in place to mitigate. So I think that mindset and the testing and the understanding of what that takes from a second and third line perspective is incredibly important from a machine learning, engineering, and MLOps perspective, especially at a financial institution. We understand what we need to do to satisfy the needs of those second and third line areas, the departments, but we also know enough about the paradigm of controls to start adding them as appropriate into our pipeline. So just as an example, the approval that we have within Bitbucket. So the fact that you can't put any code into dev or main without an approval, that's a control, right? It means that there is a second review of, and it's not like it's a control that is different from a lot of, I mean, it's a pretty standard Git flow approach, but it's definitely something that we would call out as a control, and it's a control improvement over not having version control at all. Another example of a control would be the monitoring pipeline. The fact that we consider that to be a first-class citizen, that we detect any changes in our environment from a statistical perspective. That's, I don't know if a lot of people who didn't have a second and third line perspective would necessarily have thought of that as a first-class citizen. But the fact that we have that there is one of our 3 primitives, if you will, for how we think about models is, to me, it's something that mindset came from having that background in model validation. And monitoring is very important for a variety of reasons, but I mean, if you read SR 11.7, it's called out there quite frequently. So if we can put the control in place, the automation in place, so automated controls are always, all else held equal, presumed to be better than manual controls. Mm-hmm. So the fact that we're putting these things in place that are automated, that run on a regular cadence, that automatically alert both the first line and second lines if something goes wrong, it makes the interactions that we have much more seamless and much more proactive rather than reactive.
I tend to ask this question when it comes to monitoring is, how do you stay out of alert hell? Like when you just are getting alerts for nothing and later you realize, wow, we've got, these 30 alerts and maybe one or two of them actually mean anything.
Yeah, so that's dependent on the model type from what I've been able to see. For example, you mentioned fraud at first. Fraud, you get ground truth pretty quickly. You know whether or not it was actually fraud within a couple of days. So you're able to assess accuracy. And to me, if you're lowering in accuracy, like there's no such thing as a false alert there. Like that's a problem. Mm-hmm. When you get into things where you might have to spend 6 months to a year before you actually start collecting ground truth. So if you have predictions that are far off into the future, or you might never get the ground truth on some of these, then, or the ground truth you get is biased because you're making a decision based off the prediction, which is going to change whether or not the ground truth is the validity of that ground truth, right? So in those cases, when we're looking at drift monitoring particularly, it really comes down to the understanding of the model by the data scientists. So again, we have these pipelines in place, but the data scientists have to define those metrics. We're not going to define those monitoring metrics for them. They're going to have to understand their model very well and say, this is what's going to cause a problem with the model is if it comes into this range. Another thing is we often look at data quality as well. So a lot of our monitoring will be around not just distribution of data from a statistical standpoint, but also do you suddenly have missing values, or do you suddenly have values that you didn't expect to see? So if I thought that this field was only going to have 5 values, distinct values, and now it's got 6, what does that mean? What is my model, which wasn't trained on that 6th, right? What are the implications there? So we have those types of checks as well. And again, in those cases, there's no such thing as a false positive. That's a problem. And we need to go in and address it.
So there's a few more questions coming through in the chat, and I love that you all are asking questions. Keep them coming. Thank you. This is an awesome question. What are some specific operational challenges you're facing at this moment?
So operational being, I guess I could define that many different ways. So if I was to define operational as interactions with technology, which I think is a large part of what we do. So I think historically there's been a tendency to consider a lot of what technology does for us. I say technology as a department, so IT is more of a keep the lights on function, and they've definitely made a lot of strides in becoming a change agent within the bank. Right? They're not just responsive; they're proactive, which has been great. But when I think about the term operational, I immediately go to our relationship with technology. And I know you probably are going to ask this again a little bit later about how do you have the changes that you need from a machine learning perspective in a legacy institution, or I shouldn't even say a legacy institution, but a company that has been around for longer than 5 years, which means that you're automatically going to have data that's not perfect because it's not using the most modern tools by definition. And the answer I would always have is you need to make good friends with your IT partners because they're there to help you. And just make sure that you get them on board. As long as they don't think that you're, going off into the wild, wild west and doing things without understanding what you're doing, they'll have your back. So I have not had any, I love our IT partners, right? I could list a whole bunch of them, which I would consider not just work friends, but friends. Nice. So when I think about operational challenges, I don't feel like we have all that many, just because of that relationship that we have.
Oh, that's very interesting to hear. So Adrian's asking, did you mention Python and Scala as part of deploying models? Could you expand on this, please? I've deployed models where the model is exposed via Python REST service and invoked using Scala for orchestration. Is that how you're going about it?
No, so right now, so that's an interesting question because it's typically the other way, right? You use something like Airflow, which uses Python to orchestrate your Scala jobs. So that's interesting that you use Scala to orchestrate your Python jobs. But no, we use Spark primarily and primarily PySpark. So if you use Spark, you have essentially a choice between Scala and Python. You can also use R and Java, but it's not as common. So in our case, since we are so since Spark is the fundamental engine that we use for both data engineering as well as machine learning, that's really, when I say Python or Scala, I'm really meaning PySpark or Spark. And we orchestrate. We actually use Bamboo to orchestrate our jobs. So I mentioned that we have a GitOps approach, but I really love the concept of infrastructure as code, so that one approval within Bitbucket defines everything that you need to know about the model. There's really one place to go for that approval. So from a Bamboo perspective, which again is our CICD platform, we can specify releases on a certain cadence. So if we wanted to schedule our jobs, we have the ability to set up a cron as part of our configuration as code that says this is when we're going to kick the job off. And then Bamboo will make a REST call to our job orchestrator to create that job for us. So it really goes, if you think about the cycle, it really goes code, Bitbucket, Bamboo deployment, which then kicks off via REST a Spark job on our data lake.
So when we're looking at the stacks here in MLOps, there's a lot of tools that are out there, right? And there's a lot of consolidation that's happening, and then there's a lot of tools that pop up every day, and we hear about something new all the time. And I'm wondering if you feel like there is going to be some canonical reference stack for your machine learning. Do you feel like things are going to congregate in certain areas? Is it going to be these three areas that you speak of, like your three foundational principles? And like when you look at the relationship between tools and the talent that you have working on stuff, how does that help or hurt one another?
Yeah. So I don't believe that there might eventually be a canonical data science stack. But right now the space is moving too quickly. There's too many different paradigms, right? Like think about if you're trying to do a vision model, you'd be using TensorFlow and you'd probably be using that whole, what was the word that you just used? Canonical stack for TensorFlow, right? And then you'd have a canonical stack for sklearn, or you'd have a canonical stack for Spacey, right? I mean, there's so many different ways to do machine learning that I think that it's going to be hard to find a one size fits all today. There are ways around that. So even though we're heavily Spark based, we have found that you can do NLP in Spark, but it's just not as user friendly as using something like Spacey. You can kind of do TensorFlow in Spark. So there's ways to get around that to some extent, but they're just not what I would consider like first class citizens in that Spark environment or a Spark world.
Yeah, okay.
But if it ever does come to play, it's going to be either using Kubernetes or whatever comes after Kubernetes in that container orchestration workspace. Because I don't know if you've ever tried this, but if you run Spark on Kubernetes, it is night and day different. It is so much better to run Spark on Kubernetes. And we're starting to see that with every other paradigm as well, whether it be TensorFlow or XGBoost. Like you can orchestrate these things from a Kubernetes environment, and that Kubernetes cluster can be your pane essentially into the modeling workspace. I think of projects like Kubeflow or other Kubernetes native workbenches. Argo is another one. I know Argo is behind the scenes for Kubeflow, but there's these Kubernetes-based orchestration tools that I think could become a canonical stack, and then it's just hot swapping essentially Docker containers depending on what algorithm you're needing or what your use case is. But I don't see that happening yet. That's why, to your point about those three primitives, the training, the scoring, the monitoring, that's where keep coming back to and trying to find ways to make those three things happen across use cases versus coming up with a canonical tool stack. I just don't think we're there yet.
Dude, I really like that idea of swapping out containers for the different algorithm or use case that you're using. I had never thought about that because, like you say, it is such a broad range of topics right now or use cases that you can go down this road or that road, and for each road you need something specific. And here, when you talk about that, using something like a little lower level, which would be the canonical piece or the necessary piece, and then everything else are just Lego blocks that you can swap in and out. That is really interesting to think about. And so, all right, I've got another question from one of your colleagues asking about what people should know about MLOps in banking that might be different from other industries.
So I've only been in financial services my entire career, so I might not be the best person to ask that. I can definitely say that the paradigm of DevOps and MLOps, I think, is a mindset shift that has to happen everywhere, but it definitely has happened. And well, it has to happen. It has happened at regions
Nice.
in order to make this actually work. Let's see. This is actually a hard question to answer for me, just because I don't know how it really looks at other places. I would say that probably most other places, at least younger companies that have the more flexibility, who have data set that's not sitting in a mainframe and has to be extracted from there, and that just creates a hurdle, right, to some of this. So if you didn't have those types of hurdles to have to go through, I think you'd probably start off with a more microservice-based approach where your training pipeline is done in a big data environment, and then your scoring is done in a more real-time microservice-based environment. That would be, I think, to me, that's just off the top of my head, I would think would be the biggest difference, is that in banking right now, I think it's easier to approach it from a batch-based perspective.
Excellent answer. Now, Simon's asking along those Kubernetes lines. I work in an AI tech startup that currently uses Docker containers, but want to investigate MLOps and a possible move to Kubernetes. What advantages, disadvantages do you think this might offer?
Oh my! So I'm not a expert at Kubernetes. So take what I say with a grain of salt. I will say Kubernetes is both the world's best thing and the world's worst thing, right? It's it makes once you get it to work, it just makes your life so much easier. But getting it to the point where it's actually working can be cumbersome. So I've heard people say if you're just small, just use Docker, and if that works for you, great. It's when you want to scale or create a very complex application where Kubernetes, the headache of Kubernetes starts becoming worth it. And I've even heard people say, once you learn Kubernetes, you've basically learned everyone's tech stack because everyone's using Kubernetes in somewhere. So it's time well spent. That headache pays off eventually, regardless of whether you need it for your specific use case or not. I'm a big fan of it, but it took me a while to become a big fan of it, is what I would say. And even now, there's things that cause me to bang my head against the wall when I use a Kubernetes cluster.
Well, maybe we can dive into this idea a little bit further of like iterating and adding complexity as the team becomes more sophisticated. When do you know when to bloat what you're doing or to add in more complexity?
Yeah, so that's a really great question. It's a trade-off that I'm always having in the back of my mind. So when I think about the way I want my team to approach these kinds of problems, there's really four things or pillars, if you will, that I like to think about. One is we need to meet the data scientists where they're at. I think we've kind of spent maybe 50 minutes kind of talking about that. One is, and the other one that is where we have to find the balance is always doing what you're doing with an eye towards the future and continuous improvement. And it's a little bit of a chicken and egg problem. You want to make sure that you're going to the next step and advancing things, but you also want to make sure that you're bringing the data scientists along with you. So I think the example I gave of having the data scientists deploy their code through a CI process, I think that was a mindset shift for people, but it was absolutely necessary. And as soon as they saw how easy it was to get their models into production using this method, that was where we had the data scientists just become very engaged, right? It was, just as an example, one of our first data products, when we were working through it, we were doing manual deployments at the time, which was as bad as you might think from a manual, especially when there's more complexity. Like a manual software deployment sounds awful, but when you have the complexity of data as well involved with that, you have to juggle so many things to make that manual deployment work right. And it almost never worked just right. And it was a all hands on deck thing. Every 2 weeks we had to deploy, and it was like 5 hours where everybody would have to get in and just, make that thing work. And so my team and I, if I don't know if Jesse Pritchett's listening, but Jesse was instrumental in this, was putting together the automation framework so that we didn't have to do those manual deployments. And once people realized that they didn't have to spend 5 hours every 2 weeks and they could click a button and it was a worry-free operation, they could do it on a Friday afternoon and it wouldn't ruin their weekend. That's where people started realizing the power of this framework. So that's how we approach it, right? We find real pain points and then say, well, how do we address this pain point in a way that both fixes it, solves it, but then also gives us that one next step towards where we really want to go.
So there's a few great questions coming through here, and I'm conscientious of our time. Do you have 5 minutes to go over? Or
Yeah,
you have a hard stop
I do.
right now?
I do.
All right, cool. Are there any low-hanging fruit nuggets of wisdom that you could tell us about from that deploying manually to automating? Like if I'm at a company that is right now in that 5-hour fire drill phase, how do I get to where you're at? Because I'm sure there are people thinking about where you're at and it's like, oh, that sounds so nice. I want that. What are some easy wins that we could do?
Well, so I'll talk about how I initially thought about the problem and then how Jesse, who I mentioned, fixed my thought process on it. So my first thought was we need Git to be this. So first of all, and this is true, I'm still very much of this opinion. This is how we have operationalized it, but Git has to be the center of everything. The fact that you're able to version your code and using infrastructure as code, that has to be central, because that's the only way you're really going to enable a lot of the automation. I had the idea of basically at execution time of the model itself, cloning essentially the latest version or the commit of the version that we wanted to run. And that worked, but it was a little bit flaky. And the reason that it was flaky was because not all the assets were as packaged as well as we'd want within the repo itself. People might make changes that affected the actual running of the code within the repo. And it just was a little bit weird as part of a deployment to check out a Git repo and then check out or clone the Git repo and then check out the right commit hash. So Jesse saved me by saying, hey, we're not going to use full repos anymore. We're actually just going to package up the code as a library and pip install it instead. And that's a paradigm that I think is very, very powerful. So to me, it could be Docker. Docker is the way that people usually do it, is they'll package up everything in a Docker container and be able to reuse that. In our case, just a standard Python library deployed to our internal PyPy registry works really, really well. And again, it only works because we're primarily a Python shop, which is where the reason why Docker is often used is if you're using a variety of different languages. But that's how we thought about it, was let's create a object, just like a standard CICD pipeline. Let's create a binary, let's create a package, let's create a library that we can then reuse as part of our deployment.
So reminds me of when we had Lee Talks on here from Mercado Libre, and he said, "Oh yeah, things are really easy for us. You can use any language you want as long as it's Python,
Yeah.
and then we're good." And so,
And unfortunately, that's where we're at. I would love us to get to the point where as an ops team, we don't care about the language that you use or the algorithm that you use, right? Right now, we're primarily Spark. Well, you know what? Spark ML is great at a lot of things, but it's not the best at almost anything. So I would love to get us to the point where the data scientist can say, yeah, I want to use this algorithm. I want to use this library, and I want to use this language. And when we say eye to the future, that's where we need to get to, is where the data scientists just have that full experience where they have the flexibility to choose what they want, but they don't have to worry about the implementation details. So we're not there yet, but my hope is that something like Kubernetes will get us there.
Well, that goes perfectly with this question coming through from Corey, and he's asking, based on your experience, productionizing ML, where do you see MLOps tooling technology space going in the future?
Yeah. So I think, so I mentioned Kubernetes a lot, and I don't want to sound like a broken record, but I do think that's going to be a primary, either Kubernetes or some sort of container-based orchestration. Kubernetes seems to really have the mind share at the moment. Would, just because it has the agnosticism to the underlying containers, that really makes the flexibility happen. But also just integration. So I think we've seen with things like GitHub Actions, right? We've seen, I once saw GitHub Actions called CICD 3.0, where 1.0 was Jenkins, 2.0 was Travis, and GitHub Actions is 3.0 because we now have reusable chunks of pipelines that we can just pull into our GitHub Actions workflow. I see something like GitHub Actions actually making my conceptual thought of, or the way I conceptually think about model training as CI/CD a reality, right? I can actually have GitHub Actions get kicked off by a workflow or by a trigger that's done through either manually or through my Git repo. And I can have it orchestrate model training through that environment. And then the object at the end of that, and it could take a while, but that's okay. And at the end of it, I'd end up with a model object that gets pushed to my object store, which I think GitHub actually now has an object store built in.
Yeah.
So you could do that. And then, and so you basically combined your CI/CD pipeline, or I shouldn't say you combined the pipeline, you combine the infrastructure for your pipeline. So it doesn't matter whether I'm using it for unit testing and code deployment, or whether I'm using it for model training, I'm still using the same framework. I'm still using a GitHub Actions framework.
So many banks run various applications on mainframes under z/OS or Linux. Is that the case with your bank? Do you deploy any scoring pipelines on mainframes and link online COBOL Java mainframe applications with model scoring codes? If yes, how?
Yeah, that's a great question. So we don't, because the how question, I don't even know how to start with that, the how on that. So we don't. So all our data is, all our source data, a lot of it obviously is in the mainframe. All of that is copied into our data lake currently nightly or even more frequently. So the data lake really becomes the place that we have to go to get the data. So that means that we're 100% able to use our more modern toolkit. We don't have to mess with COBOL or with Java on mainframe. There has been some talk about certain really low latency applications needing it, but we do have things like a Kafka cluster, so we're able to hook up into event-based streaming if needed. So that's something that we're thinking about in the future, especially for fraud, where we need to score transactions. Just hook up to our Kafka cluster. So there's ways, I would say, around having to put things on mainframe. We've always been able to find ways around it, thank goodness, at least up to this point.
So in your environment, how does an application developer writing Java or C++ code generate the features and invoke a model and that it is available?
So we don't have, so I think there's some certain teams or certain ML ops teams that actually rewrite a lot of the model code in Java or in C++.
Wow.
So the data science teams will be creating models that gets handed off to an operations team that literally will recode it. So that's not scalable. That wasn't going to work for us. So so that was one of the reasons why we used MLEAP, which was serializing the PySpark model, and then we could import that into a Java or Scala application seamlessly. So we're always looking for workarounds like that, where we don't have to, if we have to recode something in a new language, it's not going to scale, and that is basically not going to happen. So we look for ways to take the model object, the trained model object, and put it into a more production-friendly language, if you will. Though Python's not, especially since 3.5 and we have types now, I'm a little less concerned about Python in production.
Last question from me, and then I'll let you go. I know you're a busy man. What was the background of the last person you hired, and why did she stand out as a strong candidate?
Yeah, so the background was, I hope she doesn't mind me calling her out, but Jessica was my last hire, and she came from model validation, very similar to how I did. She got her PhD in math from UAB and got into model validation. She was one of two validators, I believe, on one of those initial models I was talking about, the one where you had to do that manual deployment. She helped validate that model. And like I said, that was a time where we all were learning so much, so quickly, not just the tech, but also the practices, right? This was a new way of kind of doing modeling at Regions, using this big data environment, was using these machine learning algorithms. And she tackled the validation problem with gusto, and she seemed to love it. And that was really what I look for, especially in a space that moves this quickly, is do you love this area? Are you always willing to learn new things? Because you can get a degree in something and then 3 years later it's completely out of date because the space moves so fast. So you always have to have that mindset of, I'm going to continue to learn. I love learning. I have a passion for it. And she has shown it. She showed it before she moved to my team. When she was in validation, she's shown it since she's moved to my team.
Awesome. Last question. I just realized there was a few in the chat that I missed.
Oh, no problem.
How do you know if a production model needs to be rolled back or not? If so, how do you do it?
Yeah. So the rollback ability is fundamental. So if it doesn't work, you need to be able to redeploy a previous version. And that's where the fact that we do version them as Python libraries really comes in handy. So if we needed to, rolling back is as easy as pip installing a previous version, right? And that's not even us doing it. It's the computer that's doing it through our CICD process. So if we want to roll back, we say release this previous version, and it would install the appropriate Python library. The question of whether we should or not, so it depends on the model. So if it's a large scale model like fraud, then we have to look at things like accuracy. And if we see a sudden drop, then obviously we're going to start questioning whether we should roll back. We haven't seen that yet. All our models have been performing pretty well in the fraud space. In other spaces, like the one I mentioned with our commercial clients, we have a very strong UAT team that's made up of the line of business. The line of business tests for changes in the model before it goes into production. So they're kicking the tires on it, making sure it meets their criteria. And once we get a sign off from them, then we do the final deployment. So they catch things, right? So if they catch things, then we don't deploy it. So it's not so much in that case rolling back as much as not deploying it in the first place.
Wow. I have so many more questions I want to ask you, but our time is up, and I was just going to start going into the ethical side of things and how you bring ethics into it. And I know ML engineers and the MLOps people, nobody wants to hear about that. So I will leave it as this being the finish. Thank you so much, Daniel. This has been fascinating, man.
Absolutely. Thank you for having me, Demetrius. This has been great.
Yeah, I mean, your insight and your transparency on this has really been cool. I think it's been super helpful for myself on how to view things, and everyone else here that is commenting in the chat, and then the people in the future who listen to it also. So If you enjoyed it, let us know, leave a comment or write us in the chat. And yeah, people are saying awesome. Very cool. Thanks again, Daniel. I cannot say how much I appreciate it and you being very candid with us and telling us all the secrets.
Yeah, absolutely. Thanks for having me on again.
Cheers. We'll see you all later. See you in Slack. All right. Bye-bye.